And welcome back, and it is the Further Maths 5 a day for the 10th of March, and let's just go straight to the first question. Right, so what do we have? So we have a function, and it wants the domain, and it's saying what is the range. Okay, this question is not too bad, and the reason it's not too bad is because, well actually I don't need the axis, do I? Is because I know that 12 minus 3x is just a straight line that goes down. Now the domain tells you the maximum and the minimum points it can be. So in other words, my minimum x is going to be minus 3 and my maximum x is going to be 10. And all I really need to know is what the y values are for those values. So I put minus 3 into my equation. So 12 minus 3 times minus 3 is 12 plus 9, which is going to give me 21. And then on the other side, put in 10. So 12 minus 3 times 10 is 12 minus 30, which is going to be minus 18. And then let's just write that the right way around. So it's going to be minus 18. Notably, these include the values, so therefore they're going to be equalities that have the equal sign as well. It's going to include the 21. And I don't write x here because it's a range, so I'm going to write f of x. And that is first question done. Next question. Okay, so Rachel makes a rectangular pen. This feels like a differentiation question. One side of the pen is a brick wall, the other side is made. Okay. Classic setup of these questions. So it's giving me a piece of information that tells me the fence is 30 meters long. So forget this like little diagram here. Basically, I've got a shape here with 3 sides, and I know, well, I'm going to call this X. Actually, what does it want me to do? Yeah, so the width of the pen is X. Right, now the interesting thing is, it's not... A real example would make it much more obvious which one the width is, but I'm going to assume the width is the shorter one here and the length is the longer one here. So my length is going to be 30 minus 2x because I know there's been 30 meters of panel used overall, which therefore means that my area is going to be, well, it's just a rectangle, so it's going to be x times 30 minus 2x. And that's going to give me 30x minus 2x squared, which is what I was looking for. Now, again, in a real exam, they do not that these questions are bad, these questions are brilliant, so let's be very clear about that. But equally, questions in the exam will be much more detailed, a lot more words, they'll probably label what the width is. I kind of fell into that one a bit by accident. Had I presumed the width was the line at the bottom, I was going to say length, but the line at the bottom, then I would have just got the wrong answer here and I would have realised what to do. But again, a real exam question will be more detailed. But point is, I've got what I needed to get. Great. Next question, using differentiation, find the maximum value of a. So therefore, in order to find the maximum, I'm going to find dA dx because that's what differentiation does. It finds the rate of change. So if I differentiate, that's going to give me 30 minus 4x. And I want to know the maximum, so I'm going to set that equal to 0. It's not a show that question, I'm just finding it, so I can just kind of do that in one go. So 30 is equal to 4x, which means that x is equal to 30 over 4, which is 15 over 2. I was going to say, or 7.5. I'm going to write down 15 over 2. And what does it want? So use the differentiation to find the maximum value of a. So therefore, a is going to be 30 times the value of x I need, which is 15 over 2, minus 2 times 15 over 2 squared. And again, calculator out, so it's going to be 30 times 15 over 2 minus, we'll be careful here, so 2 times 15 squared over 4, and that's going to give me 112.5. And what's the unit? So I'm doing this in meters, so 112.5 meters squared. Question done. Next, and I believe, yes, indeed, final question of today. The line L1 is a tangent to the circle x plus 2. So for this circle here, I know the centre of the circle is going to be minus 2 minus 1. And I know the radius of the circle is the square root of 20, which is the square root of 5 times the square root of 3, otherwise known as 2 root 5. And this says point P is the point 61. I misread the question. At the point P, right, so P is a 0.61. So in other words, I've got a circle. And again, don't worry about my diagram being precise here, but I've got minus 2 minus 1 is my centre, and minus 6, 1 is somewhere here, let's say on my circle, so my circle comes around here, and I want to know the equation, the tangent that goes through there. Now, my process is going to be, is I've got my radius, so I'm going to find out the gradient to my radius. Now, the x, well actually let's do y value first. So the y value goes from minus 1 to 1, so it goes up 2. And the x value goes from minus 2 to minus 6, so it moves across by minus 4, which gives me minus a half. which means the gradient of my tangent is a perpendicular to that. So the negative reciprocal of minus a half is going to give me plus 2. So I've got my gradient as 2. I also know it goes through the point minus 6, 1. So therefore I can say y equals 2x plus c. I'm going to use minus 6, 1. And that's going to tell me that 1 is equal to 2 times minus 6 plus c. Add 12 to both sides, it tells me that c is equal to 13, which means my final answer is, so the line L is y equals 2x plus 13. And that's my final answer of the final question of today. Again, good mix of questions today. I like the first question. The first question is one of those that's harder than, well, easier than it looks, but easy to lose a mark at the end. Standard differentiation sort of modelling question in the middle, and a nice little do you understand how circles work at the end. Let me know how you did, and as ever, do like and subscribe please, and I'll see you for the next one. Thanks all.